A long, long time ago, I wrote in assembler. Those opcodes used to make me smile. I wrote my hello world program in 16 kilobytes of RAM. No function calls, no do or for a while. I'd sit all night in rapt frustration, trying new optimizations. Forgot to sleep or eat, I would not admit defeat. Every change caused more confusion, surrounded by my own delusion. Finally came to a conclusion. I'd do a big rewrite. It's high time we reviewed our design. The code behind our system is just 2 Byzantine. We'll rewrite all the legacy and take it offline. And it's gonna compile first time. It's gonna compile first time. Did you have a BBC or a Commodore or a VIC-20? 8 bits wide and slow as hell. Or did you start out on a Unix scene, a VMS or a PDP? Your own account with email and a shell. Well, it's not like anyone really cares. We all got started out somewhere. A keyboard and a screen, listings in a magazine. We typed those games in key by key, convinced our code was typo free. But we knew that eventually we'd do the big rewrite. We were singing, it's a high time we reviewed our design. The code behind our system is just 2 Byzantine. We'll rewrite all the legacy and take it offline. It's gonna compile first time. It's gonna compile first time. Now for 10 years we've been running code in PHP and Rust and Node, but that's not how it used to be. When I learned to code, it was a different age. Turbo Pascal was all the rage, and we couldn't wait to install Windows 3. Well, 640K of memory should be enough for anybody. Multitasking code had to run protected mode. You'd work with your Bible by your side, Peter Norton's MS-DOS guide, but you already worked out deep inside you do a big rewrite. We started singing, it's a high time we reviewed our design. The code behind our system was just 2 Byzantine. We'll rewrite all the legacy and take it offline. It's gonna compile first time. It's gonna compile first time. Dial-up modems training to upload and spitting out sites as fast as we could code them. Share price high and rising fast. Waiting on a big IPO. We're gonna be millionaires, don't you know? I guess it was all just too good to last. Well, we thought the web was the promised land. Coded a our design. The code behind our system is just 2 bytes in time. We'll rewrite all the legacy and take it offline. It's gonna compile first time. It's gonna compile first time. And there we were shouting out loud, move everything to the cloud and host it on virtual machines. Elastic scale to cope with load, infrastructure built on code, though no one's sure what DevOps really means. Well, I sat and I watched the counters climb, wishing I got paid over time. Then MongoDB failed. I guess it wasn't quite web scale. We lost the whole availability zone. I couldn't get tech support on the phone. That's the point when I wish I had known they had done a big rewrite. We were singing, it's a high time. We reviewed our design. The code behind our system is just 2 bytes in time. We'll rewrite all the legacy and take it offline. It's gonna compile first time. It's gonna compile first time. I did my time, paid my dues. I did my exit interviews, turned around and walked away. Tired of working for the man. I had a dream, I had a plan. This time I'd do everything my way. Launched the perfect MVP online for all the world to see. Working in a new style, fast and lean and agile. I tracked all my feature requests. I wrote my code with unit tests. Then one day, you know the rest, I did a big rewrite. It's high time we reviewed our design. The code behind our system is just 2 bytes in time. We'll rewrite all this legacy, take it offline. It's gonna compile first time. It's gonna compile first time. We were singing, high time we reviewed our design. The code behind our system is just 2 bytes in time. We'll rewrite all the legacy and take it offline. And it's gonna compile first time.
Something's coming. Maybe it's Moriarty. Maybe it's not.
Come on, Tom. Let's finish this the way we started.
Together!
I was raised to do one thing. But I've got nothing to fight for. Take a seat.
Come on, Wolfie.
I've lived for over 2,000 years. And not all of them were good. I've made many mistakes. And it's about time that I did something about that.
Good morning, NDC. How you doing? How are the party hangovers? I've agreed to postpone mine until after lunch. Welcome to Learning to Love Legacy Code. My name is Dylan Beattie. I am a CTO at a company here in London called Skills Matter. I run a .NET user group. I have been building code and running websites and applications on the internet since 1992, basically ancient history in internet years. And I spent a good part of my career from 2003 until at the beginning of last year working for these people, Spotlight, the home of casting. Spotlight is often described as the LinkedIn for actors. It is the tool and the platform that is used by Lucasfilm, the BBC, the Royal Shakespeare Company, the people who make all of those shows and movies that we just saw in that intro sequence there, to find the actors who they place in those films. That's how films get cast. Casting is part of how films get made. Now, how many of you have seen Star Wars: The Last Jedi? How many of you liked it? How many of you didn't like it? How many of you didn't like it because they used classic ASP to find the actors? You don't care. That's not why you didn't like it. The things about it you didn't like. That code that I created in 2003, some of it, that is still running in the tools that are still being used to make those movies and those TV shows, it is part of a journey that exists to produce a product, and we don't care about the code as consumers. The journey that exists there is about making movies and making TV shows and putting on plays and that kind of thing. And the legaciness of the code is kind of irrelevant to that. So that's, one of the things I want to talk to you about today. I was at Spotlight for 15 years. I literally joined as webmaster. I built 1.0. I hired the team who built 2.0. I mentored the team who built 3.0. I was the architect on 3.5, and I occasionally go out for the beers with the people who are still trying to ship 4.0. Which is engaging. But I've seen this one code base evolve over literally 15 years, and had that experience where we get some contractors or some new developers, and they look at a piece of code, they're like, this is a piece of crap, the person who wrote it was clearly insane, who let them near a keyboard? And because I have that historical context, you can sit down and go, right, let me explain what it was like the day we wrote this. These things didn't exist. Stack Overflow didn't exist. These things still happened. We still made books. How would you have solved the problem? And they kind of go, yeah, maybe they weren't insane after all, So that's one of the things I want to talk about, is a perspective on legacy code bases from somebody who literally worked on a code base for so long it became legacy while I was still working on it. The other thing that I want to talk about is the rate of change that exists in software and in technology. This is an iPhone. This is just over 10 years old, 2007. This is an iPhone 1. Now, even if you could find one of these, and you could find the right kind of cable, and you could plug it in, and you found one where the battery was still working, if you booted this thing up, it's basically useless. Because this phone is part of was part of this huge connected network of platforms and tools and services and applications and protocols, most of which do not exist anymore. They have been upgraded. You can get this thing up to about, I think, iOS version 5 was the highest upgrade for the original iPhone 1. And you can't run modern Twitter or WhatsApp or Snapchat or anything on iOS version 5. They just don't work. You have to find a 7-year-old version of Twitter, which will go endpoint not found. It just doesn't work. The entire industry within 10 years has turned upside down so dramatically that the beautiful irony is the only things that this thing will do today are make phone calls and send text messages. It's still a phone, because that hasn't changed. Now, if you went out, this retailed for what, about $800 when it first came out, about £600-700? And if you had gone out the day the iPhone 1 was released and you had bought a washer dryer, or you'd bought a guitar, or you'd bought like a hammer drill or something, that would still work. You'd still have that in your house and it would probably still be going strong, you know. But we've just kind of got used to this idea that mobile phones get replaced every 18 months because that's what everyone wants us to think. And besides, that means they don't have to work out how to make batteries that last more than 2 or 3 years. Now, with the mobile phone industry, they have so much money and so much influence and such a powerful marketing machine that we'll just kind of roll with it. Well, yeah, new phone, 18 months, time for an upgrade. The organizations that we work in, the bespoke code bases that we run, we don't have that option because we are not dripping in billions and billions of dollars of cell phone revenue. We have to maintain the stuff that we build for a while, for a long, long time. Let's take a little nostalgia trip.
No one told you life was gonna be this way. Your job's a joke, you broke, your love life's the old way. It's like you're always stuck in second gear. When it hasn't been your day, week, your month, even your year. But I'll be there for you, 'cause I'm there for you too.
Is anyone enough of a Friends fan? They can tell me which season that's the opening for? Season 8, 2003. So that was airing. That was the biggest rating show on British TV in the year when I wrote the code that they used a couple of years back to make Star Wars and Doctor Who and all that stuff. And it's still running. It's still there in production. It's written in JavaScript. It's written in classic ASP. It is legacy code. Now, you know, we all agree that legacy code exists, right? You all come to a talk about it. Clearly you think it's a thing. And you can get books about it. And you can go on training courses about it. But when we talk about legacy code, what do we actually mean? Here's some code. I want you to tell me, but on a scale of 1 to 10, how legacy is this? I mean, we got this, for some reason, we run out of memory without this. Surely they'd have fixed that by now, right? You know, this must be pretty, but it's hard to tell. You can't just look at a piece of code and go, is this legacy code or not, you know? So I've invented this. This is the Legacy Codeometer. And what you do is you stick it up on your desk with some Velcro and you plug the USB port here into the back of your laptop. And every time you open a file in Visual Studio or VS Code or whatever, it tells you from 0 to 20 how legacy the code is. So you know what it is that you're dealing with here, right? Yeah, that's going to solve the problem, is it? This piece of code with this, for some reason, we ran out of memory without this eek, was shipped by John Skeet yesterday. This is a bug fix in the latest version of Noda Time. This is not legacy code. But the point is, you can't look at the code. Legaciness is not a property of lines of code. Code is just code. It's the same code that it was when it was written, wherever it was written, by whoever wrote it in the first place. So we need to understand what it is. What is this actual situation we talk about when we talk about something like a legacy code base? So if we go on Wikipedia and we look up legacy code, we get this, source code that relates to a no longer supported, citation needed, or manufactured operating system. And then it says the term was first used by computer scientist George Olivetti. And then there is this little citation. And the citation links to this article here, Sam Mullen, Legacy is not a bad word, which says, legacy code, the term was first used by computer scientist George Olivetti. Wikipedia. I've never heard of George Olivetti. Nobody has ever heard of George Olivetti. There was an Olivetti computer company, but as far as we know, it wasn't started by a guy called George. Is George here? Is Mr. Olivetti in the room somewhere today? So this is not a terribly helpful definition because it's just Wikipedia citing its own thing. There is a very famous definition from this guy, Michael Feathers, who literally wrote the book. He's been working with legacy code for years. He does fantastic training and presentations and books about it. Legacy code to him is simply code without tests. Now, I think this is the truth, but I do not think this is the whole truth. I agree exactly with what he says, but I think there is more to it than that. And there's a definition that I've been using in meetings for a while now. Legacy code is code that's too scary to update and too profitable to delete. That's why it's still there. If nobody's using it, delete it, get rid of it. That's not legacy. We just cleaned up, it's gone, Legacy code bases are the things where we are wary of changing them. We are afraid to modify things because we don't know what's going to happen. There is a risk associated with it. But at the same time, rightly or wrongly, we believe that it is necessary. And legacy code in a lot of industries, it's code that makes money. That's why it exists. When you're greenfield and you have no customers, your code base is pure and beautiful and elegant. And the day after you ship and somebody says, yeah, we'll give you $5,000 if you do this, that's when the legacy starts. Because at that point, you have something you can't change, otherwise they're going to take that $5,000 away, or $50,000, or $500,000, or however much. Now, first time I gave this talk, there was someone tweeted this slide, and somebody sort of called it out and said, I think something very similar from J.B. Rainsberger, who's another very, very smart person who works on similar things. Now, I believe, came up with this quote independently, but I wasn't the first person to do it. Very profitable code that we are afraid to change. So there seems to be this sort of some kind of consensus. Now, let's talk about that idea of afraid to change. What is it that is scary about it? And the thing that's scary about it is the unknown. One of the oldest business practices that exists anywhere in the world. Does anyone tell me what this is? Double entry bookkeeping. When you are working out how much money your company has, income and outgoings, expenditure, capital, revenue, all these kinds of things, you do everything twice. Every transaction gets recorded in two places. And then at the end of the day, you add up everything in this side and everything in this side, and the numbers should be the same. If the numbers are not the same, there is a mistake somewhere. Something's gone missing. You've carried a 1 that you shouldn't have carried. There's been an error. Something's gone missing. Someone is sneaking money out of the till. It gives you 2 points of reference. Now that is, I think, Michael Feather's quote about code without tests. A code base with unit tests, the decisions about what that code should do are reflected in 2 places. There is the code, and then there is the test, which says, is the code doing what we think it does? The double entry bookkeeping, this is what happened, and this is our double check. Did what we think happened actually happen? Now, often in the kind of early days, particularly on small projects or where you've got a very, very small team of developers, there are still 2 sources of truth about what the code is supposed to do. Have you seen this? Why you shouldn't interrupt a programmer. So if C equals comma backtrack 1, and I'm sure you can all relate to this, you get this little process. So we set a backtrack, and this happens, and this happens, and this happens, and you've got this elaborate kind of mental crystal thing floating in your mind. That goes here, that goes here. And then someone comes over, hey, I sent you an email about the thing. You want to sign Gina's birthday card? Did you get cake? Should we have coffee? Did you see TV? And boom. And you're like, okay. If C equals comma backtrack. We have this. In a lot of projects, our concept of the solution exists in 2 places. One is in the code, the other one is in your head. And this, when you have that thing where somebody looks at a line of code and they're like, oh yeah, that's wrong. That's what's happening. Now, this is the fastest documentation anyone has ever invented. This is faster than Wikipedia, faster than the manual, faster than Stack Overflow. It is the mental model that is hovering there just behind your eyes while you look at the code. And when you are working on a kind of single developer just cranking out code, one of those massively productive things where you're kind of not worried too much about what the rest of the team does and you haven't written any documentation and stuff, what you're doing is you are closing the gap between your mental model and the code that is on the screen in these very, very, very rapid feedback loops. Sometimes not even waiting for unit tests. You type something, you look at it, you're like, that's not going to work. Backtrack, type it again. Backtrack, type it again. Bang, bang, bang. Right, I think this is probably good. Done, compile, grab a coffee, go back to it. And this is fun, This is a really, really, it's fun. There's also studies that show this actually releases dopamine, this rapid feedback problem-solving process. It's addictive, the same way that gambling and cocaine are addictive. You can get hooked on doing this. And it's one of the few addictions you can get paid for being good at, which puts us in a slightly weird position as professional developers, There is a fantastic talk Jessica Kerr, Jessitron, does about something called symmetricism, and I want to borrow one of her slides for this bit. Because one of her observations in there is that the process of invention, making new things, feels like going downhill. It is this kind of smooth, easy, creative, fun process. Analysis, where you're looking at something that already exists and trying to understand it, is the other direction. Downhill invention, uphill analysis. Writing code is easy and fun and fast. Reading code is difficult and slow, and often it's nothing like as much fun as sitting, cranking out lines and methods and routines and stuff. We all know this, At least I hope we all know this. Is there anyone in here who hates being a programmer and their just boss sent them here? We can talk afterwards. And then Alberto Brandolini came up with this fantastic post about something called the Dungeon Master. And the Dungeon Master is the person who has the documentation for version 1 in their head. They are probably the person who wrote the first version of the system. They are the person who everyone is frightened they are going to leave. And it's a really, really good post. Go and look it up. And what he's doing is he's talking about patterns you can use when you find yourself in this situation. You have the Dungeon Master who wrote version 1, and now you're like, this isn't working. This person has become a critical dependency. We can't scale. We can't parallelize. We can't outsource. What do we do about it? And he explores some of the options. Do you make the Dungeon Master the product owner? Do you make the Dungeon Master the tech lead? Do you put them in a clean room and just pay them to keep quiet while you do a re-implementation of what they've done? But this is a situation that we find ourselves in. And it's easy to say at something like NDC, well, obviously, we don't do that anymore because we have pair programming and we have Agile and we have Scrum and, we have all of these really, really good. And, I do believe they are good. These patterns and practices, we've learned that running your entire company on a code base with no documentation except what's in one person's head is maybe not the best way of building sustainable businesses, right? But we are not talking about the code we are going to write on Monday, or the code we're going to write next year, or the project that we're going to start in the fall. We are talking about code that already exists, and that code, about this much of it is serverless F# microservices. New and shiny, they can't possibly go wrong because they're serverless and they're F# and they're microservices. And then we've got ASP.NET with some tests, where somebody had a couple of weeks where they put unit tests on things. Visual Basic 6 on Windows XP runs more of the world than you credit. Anybody who got here today on a train or an airplane or a bus, probably somebody used a VB6 application at some point in allocating you that ticket that got you to this venue. And then there is the code that actually runs the world, which is Excel spreadsheets. It really is, Philin Hermans has this great talk about how Excel is the world's most popular functional programming language. Because it is, Excel has no side effects. You have to build a declarative model where each cell can only reference every other cell. But so much of the world we live in runs on little homebrewed Excel spreadsheets, built by people who would never call themselves developers, but they've worked out how to use a machine to solve problems and make their lives easier and stuff. And so, how do we end up with this? How do we get to a point where all this stuff down here is running the world, but we're not interested in that? Nobody here wants to work on Excel spreadsheets. We want to be doing this stuff. And maybe this stuff, and going out and doing Rust and Go and all of these kind of cutting-edge JavaScript, progressive web application, mobile Xamarin. That's the kind of stuff you come to MDC to learn about. Not Excel spreadsheets. Why? I think a big part of it is fashion. We're human. We want to be like doing new exciting things. We want to feel like we're part of a tribe. We want to feel like we're up to date with what's going on. We don't want to feel like we're getting left behind or isolated or anything. And a big factor in this for me is the relationship that the technology industry has with recruitment. Because I've talked to people, at Spotlight, I had people leave the team who are like, I'm not learning anything here. I'm like, you kidding? You're learning how they make Star Wars. They're like, yeah, but I'm worried that if I don't know Angular, I'm going to become unemployable. And you have this person on the left here. They got the resume: 3 months of Angular, 6 months of Blazor, 3 days of WebAssembly, 4 weeks of Rust, 2 weeks of Kotlin, 10 minutes of Elm. And this person here, C#, SQL, HTML. And this is the message that people are getting. Now, I'm not saying here I think people are mercenary. One of the most important factors in whether you feel comfortable and safe and you enjoy your own life is you're not worrying about stuff. You're not worrying about security. You're not worrying about, if I lose my job, will I be able to pay my bills, feed my kids, go on holidays. And this plays into that in a big way. People want to feel like if whatever you're doing right now doesn't work out, it's going to be easy enough to walk into another role. And we keep sending this message that you have to stay up to date. Now, there are very few real important problems in the world that you could not solve with C#, SQL, and HTML if you had to. That gives you behavior, it gives you presentation, it gives you storage. Those are the three kind of fundamental propositions of von Neumann's computing model. But this person here, everyone's like, oh, they're a dinosaur. They still think HTML's a good idea. Like, don't they know about Angular, React, Vue.js, Webpack, Bower, Maven, Node, Grunt, Gulp? Did I miss any? So I want to explore that idea about, fear and why we are afraid of getting left behind and afraid of making changes to legacy systems.
Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering.
You know what suffering leads to? JavaScript. To me, fear is about a lack of three things. Confidence. The opposite to me of fear is not courage, it is confidence. And confidence is understanding, trust, and control. Now, the hardest of these things is trust. We have this expression, and we're talking here, do you trust the systems you're working on? Do you trust the hosting provider? Do you trust your colleagues? Do you trust the people making decisions? There are all these factors. If you trust everything, cool, headphones on and you get on with what you're doing. If you are constantly shipping code, and anyone here have those unit tests that just like fail one time in 3, and you don't know why? And so whenever you get a failing test, you're like, it probably wasn't me. Let me run it again and go and get a coffee and come back. And you're like, oh, third time lucky, run it again, And you don't have trust there. You're having to check and double check and triple check these results. If you have a rock solid test suite, you're like, oh, red, I did something bad. Let me fix it. Bang, done, ship it. It's all green. We're literally going to press deploy and leave the building. And we're going to be over the street having beers by the time the code goes to production because we trust the process that much, And trust is wonderful, but trust is, the expression is built in drops and lost in buckets. I have this laptop here that I've been using for the last 3 or 4 years to do these kinds of events, and it has, touch wood, never blown up on me yet. Now, if it crashes on stage once, I would be like, useless piece of crap. Those 4 years, day 1, it's like, new laptop, I'm not sure about this. Day 2, okay, day 3, 4, 5. First couple of weeks, you're like, this is pretty good. First couple of months, you're like, okay, now I trust it. Now it's like, don't leave home without it. But all it takes is one, catastrophic, unexplained failure, and you're like, well, there we go, we're back to square one. The trust is gone, and you've got to start rebuilding it. And this is true of, like I said, people, hardware, networks, all of the dependencies that you rely on to be part of a team that's shipping stuff people are going to use. I don't have a magic bullet for that. I have no answer for trust. It takes, just build it over time. Let's talk about understanding and control. Now, one of the biggest things that we find in our industry is how do we train people to be good at their job? Not just good at the wider sphere of how do you develop software, but how do you add features to a particular code base or work on a particular project? Now, anyone in here have a computing science degree? Like you've been and actually sat in a room for 3 years and learned how to be a scientist who does computing. Because I did this. I did a 3-year undergraduate at the University of Southampton, which is one of the best computer science and electronics universities in the UK. And we just learned, like year 1, we built little programs in a whole variety of things. I built little programs in Lisp and little programs in Java. And then in second year, I built little programs in Awk and Sed and Prolog and all these. And the third year, I built, one of the cool things about Lisp is you can build little programs that actually do quite a lot of stuff. We built a Lisp interpreter in Java, but these were still, there was nothing in my entire undergraduate thing which I couldn't, if I needed to, get some Red Bull and do in a weekend. It taught me a lot about algorithms and data structures, but fundamentally, it feels to me a bit like this. You got to, building school, and year 1, they're like, we are going to build wooden sheds. We're going to teach you all of the techniques necessary to create wooden sheds. And second year, they're like metal sheds. And third year, the really advanced class, glass sheds. And you're like, that's it, I'm qualified. I'm a building architect now, I know how to do things. And you walk out into your first job, it's like, hey, I'm a developer, and they say, we need one of these. And you're like, I got this, Because we don't teach, the classical computer science education is not about teaching someone how to dive headfirst into 250,000 lines of Visual Basic code and make any sense of it. They teach data structures and algorithms. And one of the things that university did for me really well is it taught me to learn things in a hurry and then forget them quickly when I was finished, which is a very valuable skill. So, we're not coming out of school with the skills we need to go and work on your company's massive monolithic legacy code base. So what we do is we hire people, and on day 1, we sit them down and we go, right, take a couple of days to read through the code. Anyone read these? All of them? In order? Anyone know how many words there are in the complete Harry Potter? just over 1 million. And these hardback editions, the average about 8, 9 lines. So we're talking somewhere between 100 and 120,000 lines in the complete Harry Potter system, yeah? 120,000 lines. Now, let's do a little comparative analysis here. I'm going to put some stuff up on here. So this is Hamlet, it's Moby Dick, The Brothers Karamazov, The Lord of the Rings, Atlas Shrugged, War and Peace. This is number of lines, the Linux kernel, and mono. Now, what's wrong with this graph? There's no numbers. I am lying to you with statistics because this is a logarithmic scale. On a linear scale, it looks like this. Now, the Linux kernel is generally celebrated as being a relatively tight, cohesive, small project in terms of the complexity of the code. It is widely understood, it is widely documented, it is kind of, they had this very, very minimalist approach. Don't put crap in the kernel, put that elsewhere in the system. So the Linux kernel is a pretty good example of a small code base. The Linux kernel is bigger than War and Peace, Atlas Shrugged, Lord of the Rings, and the complete Harry Potter all put together. And that's small. You know, it's about 100, 120,000 lines. So saying to someone, read the code base, is like bringing them in on the first day, going, read all of these books. Give them a couple of days. Then you come in on day 3 and you're like, yeah, we need you to make a change to scope. You're like, what's the change? You know Hedwig, we're going to make Hedwig a pig. Tell us what's going to break. And I'm like, okay, and you're thinking, okay, so there's the bit of page, Hedwig flew through the window. Yeah, that's not going to work, you know. But to work confidently on a code base where you don't have tests and you don't have documentation and you don't have, you know, integration and monitoring stuff, it's exactly like that. It's like someone giving you 3 days to read all of Harry Potter and then saying, well, you want to change Hedwig into a pig, give us a list of everything that's going to break and go and fix them all. You know, this idea of you read it, and after you read it, you understand it, and then when you understand it, you can work with confidence, I just don't think it's realistic on code bases of any substantial size. We need a better way of understanding things than reading. Richard Feynman, one of my sort of personal great heroes. I love the way he approached science and the study and the teaching of science. He won the Nobel Prize for Physics for creating something called Feynman diagrams. He wrote a corollary to the investigation into the Space Shuttle Challenger explosion, which NASA refused to publish officially because it said a lot of nasty things about them that no one else was prepared to say. But during the 1960s, the government of Brazil approached Feynman and they said, we want to teach science in our schools better. We don't know what's going on. All of our kids in our Brazilian high schools are getting great grades in science, but then none of them are getting jobs in science. None of them is working in laboratories. We have no innovation. And so for a couple of years, Feynman would go down for a couple of months every year, and he'd go to the carnivals and he'd play bongos, and he would talk to teachers and educators. And his finding, he came back to the Brazilian Board of Education, he said, the problem you've got is you're teaching your kids the answers to the exams, you're not teaching them anything about science. He said, I stand them in front of a room full of kids and I say, what is the name of the phenomenon that is exhibited when a crystal is deformed under pressure? And they all put their hand up and they say, scintillation or triboluminescence. And then I say to them, you ever go home and go in the closet, close the doors and crush a sugar cube with a pair of pliers? And none of them has ever done that, you know. None of these kids has any idea that the phenomenon we are talking about is when you crush sugar in a dark closet with a pair of pliers, you get blue sparks. They just know that if they see these words in the question, they get these words in the answer. They are learning by rote. They are not actually learning by doing. They are not developing any understanding because they are not doing experiments. Now, I am a big fan of something we call the scientific method. This is the basis of pretty much all experimental science. You begin with an observation. You look at something. You think, all right, let's not mess anything up yet. We'll just, stare at it for a couple of days and see what it does. And you formulate a hypothesis. We keep getting this error message crop up in our log files. I think that error message might be because one of the database columns is not wide enough for the user agent strings that modern browsers are sending to our platform. You design a prediction. You say, I think if we increase this column to 256 characters, we will stop getting out-of-range errors from web visitors visiting our site. You conduct an experiment. How can I validate whether my prediction was correct or not? You analyze your findings. Maybe you do this in a sandbox environment. Maybe you do it in production. Maybe you do it with some kind of simulation. You communicate. Maybe you write a blog post. Tell the rest of your team, share it, send an email. Say to people, hey, you know, I noticed this, I thought it might be this, designed the experiment, I ran the experiment, looked at the results, here's what I found. And often what comes out of the analysis is you modify your hypothesis. It's not the width of the field, maybe we're getting extended Unicode characters in browser user agent strings coming from somewhere. Let's see if we change it from being a varchar to a Unicode character, maybe that will fix the problem. You go round and round this cycle. Now, the problem with science as a software engineering technique is that at this point, and this point, and this point, and this point, and pretty much all the way around this loop until you solve the problem, you have no idea what you're doing. You are like, 250,000 lines of Visual Basic, and well, let's poke this bit and see what this does. And so to be able to use this as any kind of effective technique for working on code, we need ways that we can run that code without breaking anything. We need sandbox environments. Now, how many of you have ever taken a code base that you're working on, git clone or whatever, or subversion checkout, or visual source safe, or whatever you're stuck working with, put it on your laptop, switched off the Wi-Fi, and run it? How far does it get? Yeah. Because a lot of the systems we build now, there used to be a day when you could check out the code, you could press run, and there it was, a little console application or your WinForms application. But what we tend to build now are components of distributed systems that talk to other services. They talk to databases. They send emails. They pull in stock ticker prices and weather reports and all kinds of stuff. It is very, very difficult to run most. And when I say modern here, I'm talking about stuff that was cutting edge 10 years ago and now we don't know how to switch it off. That kind of modern, kind of first wave of distributed systems engineering, which is now very, very prevalent in a lot of organizations. It is hard to run those things in a sandbox and understand what they do. But there are techniques you can use to do it. Get a local copy of the database, that's step one. If you have services, it's often like we can't run that service locally. Something that I've done many times is I've literally gone into my hosts file and I've said, right, I'm going to run this thing with a network tracker and I'm going to see every single address it's connecting to. Then I'm going to use hosts to point all of those at localhost. And I'm going to run something on localhost that just tells me what requests are coming in. And it is amazing how often you can effectively simulate an entire, so the API, like a payments API gateway, most of the time for what you're doing, all you need is it to send back OK. If you're just testing something else that at some point requires a payment to be acknowledged, put a JSON file that says OK in a folder and expose that over HTTP using a local loopback server. Your code makes a request, gets a response, you keep on doing what you're doing. You can systematically isolate the components of the system you're working on. Now, I'm going to put a very explicit caveat in here. If you're working with message queues, be really, really, really careful. Because a message queue will quite happily go, oh, there's no Wi-Fi. All right, I'll put them over here. And then you get back in the office and you switch the Wi-Fi on and it's like, I got 1,000 customer emails I'm going to send now. Test, 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 test. And if it's misconfigured, it can feed those into a real system, which goes, oh, emails, yeah, I know how to send those, and send them. So if you're working with real-time synchronous systems, if it failed on a plane, you're probably all right. If you're working with any kind of asynchronous or message queuing system, be a little bit more careful. Like at the very least, when you switch it back on, look at what's coming out of the network on that. But you can reach a point where you have your code running in a sandbox. It's up on a workbench. It's in the laboratory. You can start experimenting with it. Now, the next thing, you have the scientific method. You have a hypothesis. You have a prediction. You have an experiment. You need a way of getting your changes shipped. You need a way of getting the stuff you've done through into production in a way that you trust, in a way that is reliable and reproducible. And this is where we get into this idea of continuous deployment. Now, I've worked on projects, I'm sure you all have, where the deployment process is you put the right DLLs in the right folder on the right day, and then you send the right email to the right person who copies the right DLLs from that folder to the other folder on the other server. And if anyone makes a typo or misses something or skips a step or is off sick that day, the process doesn't work. And so you don't do it very often. And because you don't do it very often, it gets scary because no one can remember what happened last time. Continuous deployment. I used to work with a guy whose mantra was, if it hurts, do it more. We're scared to deploy to production. All right, let's do tomorrow and the day after and the day after. Even if there's nothing to deploy, we'll do it over and over and over again. And the way to validate this process is you put a kind of like a software tracer bullet right through it. Go onto some obscure page like the Contact Us or the Terms and Conditions on your website and see if you can add a comment at the bottom of that page that just says verified and the date. What does it take to get that comment to come out the other end of that release process so you can see it on a public-facing web page? In some organizations, that could take months. You want to get that down as tight as you can. If you can get it down to minutes, that's brilliant. Get it down to the point where you just check it into Git and there it is a couple of seconds later, you're absolutely winning. Because one, you want to change something, you can get feedback really quickly. Two, if you need to roll back because something behaved in an unexpected way, it's also very easy. It gives you confidence. It gives you trust. It helps you develop understanding. Now, one of the interesting things that I've noticed about legacy systems is how cutting edge they were when they seemed like a good idea is directly related to how easy it is to keep them alive. There's a bunch of code that I wrote for Spotlight back when Friends was on TV, which is in classic ASP, using JScript and COM objects. Do you know how you run classic ASP on Windows Server 2016? You tick this box. It is still there. All of that code, literally, you can copy and paste, and it will run right now on an Amazon EC2 instance running Windows Server 2016. Because classic ASP got to a point of maturity where it was baked into the operating system. And Microsoft is very, very good at going, we're not going to break stuff that people have paid money for, apart from Zune. I'm sorry about that. But, you know, and so classic ASP still works. And because of that, we lose the understanding of what exactly is involved in doing it. Do any of you know how the brake light on your car works? You push a pedal, the light comes on, yeah? And one day you push a pedal and the light doesn't come on, and a couple of days after that someone tells you about it. Those are interesting days. But do you know anything about how to maintain this system? Do you know how to install it? Do you know how to make changes to it? Do you think this person knows how to maintain the brake light system on their car? The stuff that people are good at maintaining is the stuff that doesn't work. And a lot of the time, the legacy code, the stuff we're scared to change, the reason we're scared to change it is that it actually works pretty well. It's in production, it's purring away smoothly. No one can remember how it got there or what it's doing while it's there, but it's live and the money is coming in and people are buying things and making movies or selling airline tickets or whatever it is that your organization is doing. And so we have this kind of weird situation. The stuff where you very rapidly get familiarity is often the stuff which is not terribly good in the first place. The stuff which surprises you is when someone's like, this system's done. You're like, I didn't even know we had that system. And they're like, yeah, it made us a couple of million quid last year. You're like, really? I didn't know about it. They're like, yeah, it never broke. It just kind of purred away quietly, like the brake light here on your BMW. And so one of the most valuable techniques we can use to promote understanding of these kinds of systems is transparency. We want to go into the systems which are working, the ones that everyone has kind of forgotten that they're even there, and we want to say, well, what are they doing? I've always loved the fact in Star Trek: The Next Generation, the engine is part of the set. There is this huge thing in the middle. Now, I happen to know, because it's insider show business knowledge, that the engine here is an ultraviolet disco light in a tank full of gin and tonic, because that's what gives it that. That's how they get that blue Cherenkov radiation effect on TV shows and stuff. But this was part of the set. And if you ever watched Star Trek: The Next Generation and you saw the engine room and this thing was not glowing blue, you knew exactly what was going on. And that was the plot of this episode, is the Enterprise is crippled. The engines are down. What's happened? Why isn't it glowing? What happened to the gin and tonic? There's a problem here. We want to try and create the same level of transparency and awareness. You have these systems that never go wrong. Put something on, the equivalent of dashboard lights on your car. Is the stock control system working? Of course it's working. It's been working for 10 years. Yes, but is it working today? Is the first indicator we have that there's a problem? Do we understand the capacity of it? Are we waiting on an angry phone call? Are we about to run out of database space? We have legacy systems where someone put them in place 10 years ago, they worked perfectly. One day someone decommissioned the email that would tell you if it was running out of disk space, and it's just sitting there quietly logging a couple of transactions a day to a C drive, which has, 64 gigs of capacity, because that was a lot back in the days when we provisioned these kinds of systems. And, I think a big part of this, we as an industry have to accept some collective responsibility for the challenges that we face. Because certainly during the 1980s and 1990s, the kind of first wave of business software and business software automation, we as an industry went around telling people, buy computers, get a paperless office, integrate everything. You can fire all of your staff, and you can run your entire company from this one room. We have one button, and we push it for you before we go home. You know, we sold this prospect of business automation being this magical, you know, we automate all of the processes, and then it runs by magic. And we, as much as anybody, are responsible for this idea of software projects, like, you know, a project which has a start and a finish. And then after it's finished, the problem is solved, and it's fine, you know? We've built something, and once the thing is built, it just runs forever. And this is why we encounter this friction in organizations where they're like, why do we have 20 software engineers on payroll? We are not a software company. We sell tires. And you're like, you don't sell tires. The software sells tires. You know, your job is finding people you can plug into the software, and the 20 engineers are there because every time you find a person, they're not exactly like the people who were involved in the case study when you wrote the thing in the first place. You know, you look at any kind of classic textbook on business automation, and something that will come across a lot is manual processes have flexibility in them. You know, you go into, say, you check into a hotel, you're like, I'm allergic to carrots. They're like, no problem. They make a note on the menu, they send that through to the kitchen, the chef looks at it like, okay, no carrots for you, that's fine. You go into a hotel now, there's an iPad touchscreen. You're like, room, this, fine, MasterCard. Where's the allergic to carrots button? It doesn't exist. So you're like, I have an allergy to carrots, and they're like, oh, hang on, let me see. There's no button. I looked, you know. And that kind of flexibility, when you automate a process, what you do is you automate one person or one team's snapshot of how that process worked on one particular day when you captured that set of requirements. And this is changing. People are getting used to the idea, you know, Agile, Lean, and Kanban have played a big part in this. Of like, you don't tell us what you want and then we ship it. You tell us what you want now, we'll give it to you tomorrow. You tell us what you want the day after that, and we'll keep going around that process for as long as it takes, or we'll come back as often as is necessary so that you can keep evolving, you can keep developing the things that you're doing. It's not easy keeping track of all this stuff, you know, because we have this perception of, you know, software breaks. We got to monitor it. We've got to do this. We've got to invest in maintaining it. We've got to invest in keeping the whole thing running. And a lot of the times you look at organizations and you think, your accounting model here maybe isn't quite right. You've got 20 software engineers on staff who are maintaining a system that you cannot actually track the value streams through this organization and work out whether you're selling enough tires. I'm using tires as a hypothetical example, by the way. You don't know whether you're selling enough tires to cover that. You just know that the software is important because that's what you were told. You have to sell tires because that's what you do, and if you don't have the engineers, the software will stop working, and you will have legacy code incidents. But often the most valuable thing that you can do is you can look at a system and you go, this doesn't make sense anymore. This should no longer be here. Let's start trimming away some of the fat, some of the unnecessary. You'll upset some customers. You know, I had a situation once where we wanted to upgrade a front end on a page, a feature on one of our websites. And we're kind of digging through the logs, and it's like we got 5 people who are still using a build of Firefox that wouldn't work on it. And we're like, okay, how long is it going to take to make all this stuff work in Firefox build 38 or whatever it was? It was like a couple of weeks. I was like, what's it going to cost to get a couple of bottles of really good single malt scotch? And we'll send someone to each of those people and be like, hello, we're from Spotlight. We brought you a bottle of whiskey, and we're going to upgrade your computer while you drink it. You know, just think of other ways of solving the problem, ways of eliminating, moving the complexity out of the code base. Maybe you just decide, we're not doing that anymore. The 8 people who use this feature are going to be upset, and they might, you know, say nasty things about us on Twitter, but we can do that. We're grown-ups here. We can handle a little bit of controversy because this is the right decision for what we are doing. Think about a definition of done. The code is deleted. The GitHub repositories are archived. The database is offline. The servers are decommissioned. The team is at the beach drinking beers. This is the software system that is not going to wake you up at 4 o'clock on Sunday morning. This is what a finished software project actually looks like. We must have the confidence, the trust, the understanding, and the control that are necessary to go into the code and say, this is the right thing to do, you know. And the world that we live in today, it runs on software. Software is absolutely everywhere. We cannot get away from it. We cannot rewrite it. We don't know what it does. We can't switch it off. We're relying on it to, like I said, you know, book our train tickets and sell us tires and washer dryers and all of the things that we rely on day after day after day. And the vast majority of the code that runs the world is legacy code. It is VB and it's Excel spreadsheets and it's .NET web forms that was written before people really knew how to do unit testing properly. We need to get better at how we cope with it. Writing code is fun, you know, downhill invention. It's brilliant. You sit there with your little feedback loop and your mental model, and it's an incredibly rewarding exercise. And that's brilliant for prototyping, for R&D, for experiments, for validating new concepts and all kinds of things. But a lot of the time, the way that we actually create the most value, the way that we change the world we live in, is not inventing new stuff. It is by helping us and the people around us get better at working with all the stuff that already exists. And maybe the solution to legacy code has been staring us in the face this whole time, because what we need to do is control it, bring it into a sandbox, get confident, alter it, get to a point where we know how to make changes, and eventually, when the time is right and the understanding is there, delete it. Thank you very much. We have a few minutes for questions, I believe, which might mean somebody comes running around with a microphone, or might not, I don't know.
No mic, if you could just repeat the question.
Okay, are there any questions? Or have we achieved total enlightenment? Cool. Well, thank you all very much for coming. I'm around all day. Come and chat if you want to talk about legacy code or made-up programming languages or any of that kind of stuff. Is anyone coming to PubConf? Yeah. If I don't see you today, I'll see you at PubConf. If not, I'll see you next time. Thanks a lot. Have a good day.